Hi there, welcome back to the channel and welcome to a new mini project. This thing should be quite short. I hope it is. It's a take two on the Nordmende Skandia V24. This is exactly the same radio. As you can see, I've been working on it. I'm doing this intro at the end of this first stage. And somebody contacted me and said, I saw your series. My sister has exactly the same radio. She's having a birthday and I want to give it to her for a birthday. I want to do the restoration for a birthday. Will you do it? And I said, yeah, because this particular radio was in Portugal, so we don't have customs problems. If any of you, I've said this so many times, but it happened again today. Somebody tried to send me something and the post office simply sent it back. So we have a massive problem here in Portugal with the postal services because it brings in the customs and everything else. And usually it's a hell of a headache if something comes from outside of the EU. So there we go. I accepted the project and I've started working on it, and I'm going to do this little series because something really interesting came up. Something interesting that I had never dealt with before, and that has to do with the ferrite antenna. The one that came in was completely kaput and I had to do some surgery on that. I've never done that on a video, so I wanted to record that and I decided just to show you the result as well. Also, he wants to add Bluetooth to this, and Bluetooth to this is interesting because I want to try and switch off the Bluetooth module when I'm not using Bluetooth. If you've seen any of my other videos where I do Bluetooth, most of the time when you hit phono, Bluetooth is received, or rather the audio coming through the Bluetooth receiver is passed on to the system, but the Bluetooth module stays on all the time. And that can cause a bit of a problem when you're listening to radio because there is RF noise. There's high frequency noise that can actually interfere with the reception, with the signal that's coming through. Whenever I can, I try and switch off the module, and I use the existing switches for that. So we don't have extra switches that we have to put in. So I'm going to try and find a way of doing that with this. This one's a bit of a challenge because it's a dual selector. When you want to select phono, you've got to put long wave and medium wave at the same time. So it's a bit more of a challenge, but we should get there. So hopefully the series will be maximum 2 videos. I know it's not going to be 1 because I've got to the end of the first stage. There's still a few things to do, including a full alignment, because obviously if I messed with the ferrite antenna, I've got to do a full alignment. So if that sort of thing interests you, stick around and enjoy the video. And before we carry on, I just want to draw your attention to their website, PCBWay.com. This is where I come and get my boards from. And they've gone way beyond just doing PCBs, because if you come on here, you can get CNC printing and 3D printing. I know other people who've done it, very happy with the result. Here on the products and capabilities tab, you'll see just how far they've gone in terms of what it is they can do for you. And the other thing that's really important, if you get confused, is you come to their chat support. And during the week, this chat support is manned by someone, and you can get onto them, get their help. It really does make a difference, because sometimes this gets a bit confusing. You know, there's so much stuff to ask about and to inquire about. You might just have a question, and in this case, they will give you the answers right away. In this particular case, I'm doing this on the weekend. You can see the times here. It's closed at the moment, but it works very, very well. So whatever you want, whether you want standard PCBs or advanced or rigid, or if you want to do CNC or 3D printing, pop over to them. It's so simple. You put in your CAD file, you put in your characteristics, and they give you a price. Boom. It's fantastic. Enjoy. Let's carry on with the video. Let's take a first look at this Skandia version 2. Version 2 in that it's the second one I've done. This belongs to someone who wanted to restore it for his sister for a birthday. So I took it on. It's from Portugal, so it was sent just across the ocean from mainland Portugal to the islands. Doesn't take too long, and there are no customs issues. And on first look, it looks pretty good. The condition seems to be pretty good. There are a few slight imperfections. There's a bit of a ding on here, but that should be quite easy to repair. Some very slight markings on here. Again, most of this will come out. It's not going to need a full sanding down to the wood. So it should be easy to get this back up and looking like new. The really important parts are still here. That's working. That one is turning the dial. Indicator's moving across, so that dial string is fine. That's off, bass, long, medium wave, short wave, FM. So all the switches are working. That's good. So far, so good. Let's look at the back. Here things look a little bit different. I see a ferrite. Oh dear. The ferrite antenna has been completely busted off. It's not smashed, it's just broken, and you can glue this together. But it got knocked off its perch over there, and it was actually stuck to the back of the speaker magnet, so we'll put that aside carefully. We don't want to break it anymore. And I see something else. That is just from the back. Screw the back in, there's only one. And here is, and I can see that it broke off there, so we will be able to reconnect it. And here's the other side. Shouldn't be too difficult. I don't know where this I think is the long wave. I don't know where the medium wave is. This came out of here. I think the medium wave is going to be flying around here somewhere. I'll have to be careful when I remove this because I want to make sure that I get that. So the entire ferrite antenna is messed up. Now that's not too serious because we can actually put it back in place. It broke off the top there. I'm trying to find that other ferrite, the other coil. It's probably lying in there somewhere. So what I'm going to do now is just remove what I need to remove from here, get this thing out of the cabinet, exactly as I did the previous one. I'm not going to go into as much detail as I did on the previous one. That's just for the antenna. I'll be going through this and reporting back as and when I find anything interesting. And we'll see just how interesting it gets. In these cases, you don't want them to be too interesting because otherwise it gets really complicated, which can be a good thing. But I took this on because I thought it would be quite simple, having just finished the other one. Everything is still fresh in my mind. I've got all the documentation. So we should see some progress without too many hang-ups. I have replacement tubes for everything, even if I have to take the one. No, actually I have another one of these. So we should be okay. This is that. There's no marking. Oh, here it is. ECL 86. Okay. I've got spares, and anyway, since I've got the other one working perfectly, I've got one that I can borrow tubes from if I need to. As it is, I'm going to remove these tubes and store them away safely so I don't get any more damage. Let me get this out of the cabinet and see what we're looking at. All right, it's out of the cabinet and I've found the other coil. So I've got both coils. This one has got, I've got to find the other end. I'm sure I'll find it somewhere. I've got one end here. I've got to find the other one to connect it up, but I'm sure I'll find it. I hope. I'll find it. Now let's look at where that came from. See that mess of little wires over here? Here's 1, 2, 3. There's probably a fourth one somewhere. So at least we know where they're going to. We then need to work out where they come from and figure out which coil connects to what. I can always refer to the other model, the other radio that I've got. It's exactly the same as this one, it seems, so it should be quite easy. Other than that, what we expect is here, meaning we've got a lot of dust. We've got the sort of bent board as well, sort of sloping into the middle. It looks exactly the same as the other one, so I don't expect too many surprises. There's just a lot of dirt on here, which is quite easy to remove. Output transformer is exactly the same. There is that resistor and fuse, or fusible resistor, I suppose you'd call it. We'll just start checking. There's that one capacitor removed there. If I remember correctly, there was not much to remove on the underside, but I'll be able to see that better. Yep, there we go. Exactly the same. If you want more details, refer to the other video. I'll link it above now. So what I'm going to do is just get on with it and do a normal restoration without too much record keeping. It should be a lot quicker. I want to get this to Frank as soon as possible so he can give it to his sister for her birthday. If I remember the correspondence correctly, her birthday was on the 24th, so it's already past that, but hopefully she'll forgive him. Okay, let me get cracking. Well, she's looking rather different. I have not looked on the underside yet. I decided to clean this up because I wanted to work on the repair of the antenna, but to fit it on here, to solder it on here, I decided to get some of the cleaning done first. And once I started, well, you know me, I just got carried away, cleaned it all up. The top is completely done, front and back, and it's come out really nicely, as you can tell. This thing had absolutely no rust or corrosion on the chassis itself. So I'm now ready to get cracking on the one thing that I've been dreading, and that is the ferrite antenna. It's going to be a challenge because I had a quick look and I can't find the end of one of the coils, which is what I feared in the first place. But let's see how we get on. The first thing I did was repair the ferrite rod that had cracked, and fortunately it was a very clean break, so the joint, or rather the broken edges, were perfectly aligned when I stuck this with super glue. I didn't use any other glue because I wanted as small a gap as possible. You know, I don't even know which side it broke. I'm not sure if it's there or there. But I wanted as small a gap as possible when these two parts got stuck together. And of course, that makes no difference to the functioning of the rod. This is, after all, supposed to be non-conductive. It's ferrite, so it's really a powder that's been basically stuck together with some kind of resin, so the glue just does the same. And the fact that there's actually a break, as long as this thing's close together and there's no air gap, it works pretty well. You don't have current flowing in this at all, so it's all magnetic. So this thing is perfect. I've put the tape exactly where it was before, and this thing is now ready. So what else did we have? We had this guy, and this guy was quite easy because I had one wire loose and the other one, which is actually starting to unwind here. It's not good. The other one was actually underneath this bit of tape over here. So the other one was literally underneath there. I'll probably just put a bit of tape here anyway, just to make sure it doesn't loosen anymore. But I've got continuity between those ends. So this one is perfectly good. All right, no problem. What about the other one? Well, here's the other one. This thing was stuck on the on that plastic former there, and it was really well stuck because when I tried to remove it, and the reason I tried to remove it is that one end, which as you remember was sticking out the top, that was fine, but the other end I couldn't reach, and I saw on the on my own model that it was coming out from the underside, which is to be expected, and there was no way that I could see it, none whatsoever. This thing really sheared probably a little bit on the inside of the underside, if you know what I mean. So I tried to do something with it. I tried heating this coil, this former, so that I could pull it out and maybe get hold of the wire on the underside. This thing just started to melt. It's really brittle, but it does melt. And when I tried to pull it, it just pulled the top off. So this is just a mess. And I wondered what to do. And of course, I've got the option of using my own to repair this if I need to, but I've got another option. I took this from another ferrite core. The actual width of it is smaller, is bigger rather, but it seems to have, let's call it the same volume of wire on there. This was from the long wave section of the other radio. It's a parts radio that I have lying around. I've actually found a couple of antennas. Here's another one. This is just the rod. So I've got a couple of these lying around, and I think, actually I'm sure this thing will work. You can always adjust the capacitance. After all you're doing with this is a tank circuit at the front end. And provided that the inductance, together with the capacitance across it, forms the right sort of frequency bands, you're good to go. It's not a sharp filter at all. So this thing will work. I'm sure it'll work. And what I need to do now is I need to put this in place of the other one. There's one thing I need to be careful about, and that is I need to make sure that I've got the right direction of the windings. In other words, I've got to make sure that one is not in reverse to the other one. If you think about it, this thing is wound, let's call it clockwise like this. I've got to make sure that this thing is wound clockwise like this, because that will determine how it's fitted, slid into the rod, into the ferrite antenna rod to work, because these things actually work in series on medium wave, I think it is, yeah. The two actually come into circuit on medium wave, so you can't just use one and, you know, if you leave this out, you won't get medium wave. These things do work together. So I need to find out the orientation of these coils, and there's a pretty easy way to do that. You actually, well, let me show you first what I mean on the schematic. This is our entire circuit, and the part we're interested in is this one over here. That's where our ferrite antenna is. And here we see coil 24. That's the one that's broken apart. Coil 21 is the medium wave coil. And what I need to do is to make sure that I solder these in the correct position. I also thought I had to solder them in the right orientation because I said they worked in series, and it seems that they do not. In other words, this coil works completely independent of that one. And the way I know that is because this switch, which is the medium wave switch, actually shorts out one or the other. Look at this position. As it is now, it seems to be medium wave selected. Is that right? The schematic somewhere will tell us what's been selected. It looks like medium wave is selected, and with medium wave selected, yeah, there it is, showing medium wave selected. Okay, I was getting myself a bit confused here, but this is with medium wave selected. And what do we see here? We're looking at the tank circuit at the front end. And what we see here is we see this capacitor that gets switched in here. And this capacitor here is the one that forms a tank circuit with, let's call it that capacitor and that coil. And it only uses this coil because that switch there is switching this part of the coil to that point there. So it's not actually using this one at all. Sometimes they do. You have to align one together with the other one, and one first and then the other one. But this seems to be totally independent. Now, if you think about it, that coil, that capacitor, that's what forms the tank circuit, that coil, that capacitor, plus that capacitor, wherever you tune it to, okay? That tunes your front end. Now, when you select long wave, that switch goes up. And when that switch goes up, this line comes straight through here, that thing's completely shorted out, and then that circuit there comes into play, that capacitor, and that coil comes into play, and you're tuning long wave. So that makes sense. Yeah, it makes sense. So these two are not actually joined together. I was going to have to, well, I thought I had to be careful about how to put this on that former, on the core. I thought they had to be in phase rather than out of phase, but it seems that we don't have that problem. So I can put them any way I want. Right, now, will this work? Well, it seems that medium wave won't be affected at all, except the position of this on the core, and I can adjust that when I do the front end alignment, because obviously it's come off the core, the ferrite core rod. This one, I'm not sure because I don't know what the inductance of this is supposed to be, and that is a fixed capacitor. So I may have to experiment with a trimmer over here to see whether, you know, this thing is peaking or not peaking, but I'll worry about that when I get to it. I can always play with that capacitor. I think this is one of those little capacitors, those little polystyrenes that's actually on top, on that, on the holder that receives the ferrite antenna. So what I need to find is I need to find E and A, which connect, or E connects to 0.6 of the medium wave switch, K6. A connects to 0.5 and obviously connects to U as well. Those go to 5. And then O goes to that point there, which is 4 of the medium wave switch. So I've just got to make sure I connect these correctly. And I think the way to do it is to check which capacitors are on top. There are a few capacitors on top. I know this trimmer is on top, and I believe these guys are on top. So I just need to find those connection points and make sure that I connect the correct coil to the correct terminal point at the top. So I'm ready to experiment that, and then we're ready to carry on. Let's go back to the radio and see how we get on. All right, folks, here is the antenna in place, and I believe correctly wired. I've left the connection points purposely visible and easily accessible. I haven't tied them down yet because I need to check some things first. But let me tell you how I came to the conclusion that this was correct. First of all, these things are loose. There's a little strip of paper in there that sort of keeps it sort of taut, but it can be moved. And that, again, is on purpose. Same applies to this one. This little piece of paper is there to just keep it firm, but it can move. On this particular coil, the link is right on the end there. And then, of course, this is the one that was intact. And then I had to look at this whole thing over here. And to do that, we go to this drawing they have over here. And as you can see, it's pretty clear where things are. We've got capacitor 21 over there. That's the one with the 1 adjustment. And then on the other side, there are 2 adjustments, coil 11 and capacitor 11. Now, this is where things got a little bit weird because I was thinking that the section up here only had to do with medium wave and long wave. It doesn't. It actually has to do with short wave as well. And that is because if we look at the schematic, we can clearly see that the antenna comes in here, goes through a capacitor. It's got this coil and capacitor over here, this little tank circuit. That is the IF block. So it prevents the 460 kilohertz from exiting the antenna or coming in from another source. That is actually located on the bottom near the sockets. And then we've got this thing over here. And this, as you can see, is coil 11 and 12. And coil 11 is that one we've just seen at the top there. So this antenna signal comes through coil 12 always. And this, of course, is for the shortwave. This whole circuit here is the shortwave section. This is the medium wave, and that's the long wave. So it actually goes through that coil all the time. And if we don't have continuity from this point to that point, well, we won't get anything. And the reason I had to check everything is because when something like the ferrite antenna gets ripped off, the way this one was, you don't know what else it can rip out. So I had to check continuity from all the way through there, all the way down to that point there. Now that point there is interesting. If you look at this point here, it's got a 3000 picofarad capacitor in parallel with a 10 kilo ohm resistor. And that's where one of the sides of the long wave coil connects to. So we have to look back on the radio on the mounting here again. We can actually see this capacitor and this resistor. The resistor is on the underside, and it is indeed 10K. And we see this point, and this point is continued to there. So the way to look at it is you got to find out which side of this is the ground. And I know which one it is because underneath here is a trimmer cap. And that trimmer cap has got the fastener at this end, and it's got a ground wire coming in over there. So we know the point that we need is over here, or as it is continued on this side to that point over there. And that point over there receives, where are we? This one here. I was losing myself. This is that one that goes to that point over there. So that is the one connection of the long wave coil. And if we look back on the schematic, we now look for this point over here. We look for that 15 picofarad capacitor, and that's where the other side of the long wave coil connects to. So that point over there. And if we go back to the radio, that is the capacitor over there. So this point connects to that side there, okay? And this same point gets another one of these wires that's passing underneath that goes to the medium wave coil, and that's the wire that's going here to that end there. And then we've got to go back to the schematic, and we're looking for this trimmer cap, and that's where the other side of the medium wave coil connects to, so it's over there. If you go back on here, if you follow this one here, it goes underneath, and we see underneath there is that trimmer cap, and this wire comes to that point over there around the back. So I've got all the points connected. And then what I did was I went back to the schematic and I did the usual. I did the painting. I did the checking with the continuity meter, with the multimeter on continuity mode. Obviously you go to this capacitor, then you start from the other side and you go through here. I checked all those connections. I made sure that that was okay. And then I followed all the way through. And I checked continuity between that point and that point to make sure that this was intact. I check continuity between that point and that point to make sure that this one's intact. And just to check that this is working, what I can do is I can measure, what can I measure? I can measure from this point, from the top of that 10K resistor and that capacitor. I can measure to the top of that 15K or 15 picofarad capacitor. And depending on which position my medium wave switch is on, I should either measure this resistance of that coil or I should measure a short. So let's try that. So I'm going to put this on the top of those two components, as I mentioned, and the other side goes to the top of the 15 picofarad capacitor, which I believe is this guy over here. And what are we measuring? This could be deceptive because, let me get rid of the tone, what we're actually seeing is the resistance of that particular coil, L24. And if I press medium wave, which is the fourth switch, watch this. That's a short. If I choose something else, so I'm activating and deactivating the medium wave switch, and we see that that is working, okay? Now we need to check the other coil, and to do that, we leave that same point over there, one lead of the multimeter to that point over there, and we go to the top of that trimmer cap, and we're going to measure the resistance of this coil when this switch is on or off. So again, same switch, medium wave switch, and we'll then know whether these connections are correct. and we'll be able to measure the continuity of that particular coil. So I'm going to change this. This point stays the same. I'm going to take this guy and I'm going to connect it to here. And there we've got 2.8 ohms. Now if I change the state of the medium wave switch, I get a short. So on, off, on, off. So with these simple tests, it tells us that we can actually go back to the schematic and do a little bit more painting, because it means that the connections to this switch are correct. So I know that this one is correct. I know that this one is correct. And I know that this one is correct. And I really have to assume that the rest is fine. Now, there are a few things I don't know. If we look at this coil and that coil, I have absolutely no idea if these guys are at their optimum position, one or the other. I'm not sure. I think I've got all the wiring correct, but I'm still not going to tie these guys down until I've tested this. And I can then do the alignment, and this will be at the front end alignment, where I move this backwards and forwards till I peak the signal, which means that I will have aligned the RF front end. So that was much ado about very little, but it was interesting in that I learned a lot about how to set this whole thing up, and it gave me an opportunity to look more closely at this part of the circuit, which quite frankly very seldom do unless there's a break. And this is what's amazing about these projects. You always learn something new, or you have a different experience depending on the problems you find. If you found no problems, this would be incredibly boring. And this is where we are at the moment. I've completed that, as I've just explained. I cleaned up the faceplate and the knobs and everything else, put the new tape on there as usual. I've got it all nicely done. However, there's one task. There's one stage which hasn't even been tested, and that is this thing receiving anything at all? So having said that, I think you know what I'm going to do, don't you? I haven't even changed the capacitors. I've looked underneath once or twice, but I haven't even put it on my stand. I've changed absolutely nothing down there, but I'm desperately curious to find out if this thing's got any life in it, because if it doesn't, all this preamble is going to sort of take a bit of a reverse turn. But that's what I'm going to do now. I'm going to switch it on very carefully, and I want to see if I've got anything. Okay? I think you're as curious as I am. So what do I need to do that? I've got my bench test speaker over here. So we'll put that there. I've got it selected to speaker. And I'm going to take this, connect the speaker to that. Connect the antenna to the AM section. Antenna to the mini whip output here. Switch it on. Plug it into the dim bulb tester. Set the tester to minimum, so one light bulb on, all the others off. It's on limit. I just need to flick that switch. I'm going to select medium wave here. Put up the volume. And now, when I hit that switch, we watch that light bulb. Let's see what happens. This is maximum restriction. This is a 40-watt bulb. So it's very, very restricted. So it should light up quite brightly, and it did. But it's not a short. It's not a short. It's actually, what is it doing? It's drawing 120 milliamps, and it's passing 177 volts of the 240 volts or 30 volts, 230 volts to the radio. So what's happening at the radio? Are we going to hear anything? Oh, we've got some noise. You know what? This sounds very much like the last one I did. Haha, we've got something. That's the local station. Now, obviously, I could play with this. I'll have to do this on the alignment, but we're getting medium wave. What are we doing with long wave? Not much, but it's sounding like some sort of reception. Shortwave. Oh, I don't like those noises. think it's working. It's just very, very deaf. And it's probably because I've made no changes to those capacitors at all. Now what I'm going to do is I'm going to change the antenna to the FM antenna and hit FM. Now that's a very low voltage the radio is seeing, 173 volts, so it might not get anything. Beautiful. Whoa, that actually is pretty good. And that is with no capacitors changed, and that is with absolutely maximum restriction on the dim bulb tester. So I'm not going to, that's working as well. I'm trying to see that. It's working as well. Let me put it off so I don't push my luck too much. But this is brilliant news. It means that all the cleaning I've done is actually a good step in the right direction, because all I need to do now is flip it over, put it on that stand thing. I've got to get a name for that. And flip it over and do the change of the capacitors, and then I'll be ready to do a final test and also do an alignment. Yeah, I'm really pleased. I'm actually relieved. I'm very relieved, because it would have been rather stupid if I got nothing and smoke started pouring out. It means that the tubes are working. In fact, it seems that all the tubes are working. They might not be as strong as they could be, but they're working. So this whole stage that I've done here, getting it to this point before even doing the repair on the underside, was not total folly. And as I mentioned, the reason I wanted to do that is I wanted to make sure that I got that thing working first of all, because that would have meant, if that wasn't working at all, if I couldn't restore that, rebuild that, I probably would have had to take the one from my other radio, from my other Skandia, put it in there temporarily, because I want to get this back to the owner so he can give it to his sister as a birthday present. As it is, it's going very well. I've got 2 stages to go, 3 stages. One is replace those components underneath. Secondly, I'll need to align it, especially because that thing was messed with. So alignment is definitely necessary. And thirdly, to comply with one of his requests, I'm going to add Bluetooth to this. And what I need to do with Bluetooth, I'm going to build that board of mine, but I'm going to see how it is that I can switch it on. I believe that is, yes, that is. To get phono in here, you need to connect these two together. That's a TA, you can see that. I usually look for an empty switch on one of these, on the phono switch, and try and use that to switch on and off the Bluetooth module. As it is, I've got to connect 2, so I'm not quite sure how I'm going to do that, but I'm going to leave that for the next video, which should come out pretty soon. And so as far as this one's concerned, this video, this stage is concerned, I'm going to leave it here. Whoa, that's a great relief. Great relief. I can't tell you. So that's going to be it for this video. And once again, I want to thank you for your company. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon or PayPal. Links are in the description below. Thanks for watching. Bye for now, and stay safe.